So our goal here is going to be to find the perpendicular distance from the point 4 minus 2 to the line 3x plus 4y minus 5 is equal to 0. And so whenever you see this word or this kind of phrase, perpendicular distance, that should be setting off alarm bells in your head that you need to use a certain formula from the log tables, which is going to be this formula. And you won't have to memorize it or anything because it is on your coordinate geometry page. But this is basically the formula for finding the distance between a given point, which we can call P, and the line which is going to be kind of anywhere away from P. So this formula is for finding the distance between P and sort of the nearest point on this line to P, which is always going to be the perpendicular distance. So it kind of looks like this. And we're finding the length of this black line, which is going to be the value of D. And once you get used to using it, it actually is very straightforward. So we're going to be just labeling our values now, A, B, and C, and also X1 and Y1 to plug into this formula. And so our line is already in the correct form, which is going to be this kind of 3x plus 4y1 is minus 5. So we don't need to rearrange this or anything. We just need to label A, B, and C. So A is going to be the number in front of X, which is 3. B is going to be the number in front of Y, which is going to be 4. And then finally C is going to be the constant at the end, which we know is minus 5. And so that's it for our line, fairly straightforward stuff. And then for X1, Y1, we simply use the coordinate of our point, which is going to be the point P in the question, which is 4 minus 2. So we're also going to be plugging those in here in a second. So we can now set up our equation to find the distance D. And so we need to start off by multiplying A by X1. That's going to be 3 times X1, which we know is 4. We have B times Y1, which is going to be 4 times minus 2. So again, just reading straight away from these kind of labels that we've set up for the points in the line. And then adding on 3 at the end, we end up just adding this kind of minus 5 to the end. So that's going to be how our top line looks. And just a quick note on the absolute value here. So we have these two lines either side of our top line, and that just means we need to take the absolute value kind of towards the end. And so we can do that now in a second, but we're just going to set up what's on the bottom line now. So we have the square root of a squared plus b squared. And so because a is 3, we have 3 squared, and b is 4, we're going to have plus 4 squared, which probably is looking familiar as well because that's going to be a nice round number when we simplify that. But now what I usually do is just start to tidy things up. So we have 3 times 4, which is 12 on the top, plus 4 times minus 2, which is minus 8, and then minus 5 on the end. And this is going to be over the square root of 9 plus 16, which is going to be the square root of 25. And so we have 12 minus 8 minus 5, which is going to give us the absolute value on the top of minus 1. And then the square root of 25 on the bottom is just going to be 5, because 25 is a square number, and we know the square root of that is going to be 5. And so our final step here is going to be to convert this minus 1 into an absolute value of what it is, which is just going to be 1. So if it's a negative inside the absolute value, it becomes positive. And then this is going to be over 5. So we have 1 over 5. And in decimal form, this is going to be equal to 0.2. So the distance between this point and this line is actually going to be 0.2. And again, that represents the length of the black line here. So the length of this line D is going to be 0.2, and our little draw on here on the right. And so that is going to be it for this question.